Okay, we're here. Finally, the Hello World chapter. Input and output. I don't know, is this still playing this stupid idle game? Oh. Idle. Wait, was that the name of it? It's idle, but idle. Oh man. Those two words sound almost exactly the same, eh? We've mentioned that Haskell is a purely functional language. Whereas in imperative languages you usually get things done by giving the computers a series of steps to execute, I'm still thinking this way. When trying to do Haskell, it bothers me, yeah. Functional programming is more of defining what stuff is. Yeah, I still haven't hammered that into my head, actually thinking about when you put the equal sign, you're defining what something is. In Haskell, a function can't change some state, like changing the contents of a variable. When a function changes state, we say that the function has side effects. The only thing a function can do in Haskell is give us back some results based on the parameters we gave it. If a function is called 2 times with the same parameters, it has to return the same result. While this may seem a bit limiting when you're coming from an imperative world, we've seen that it's actually really cool. It is, yeah. It's just difficult to think in that way. Zoom in a little bit. In an imperative language, you have no guarantee that a simple function that should just crunch some numbers won't burn down your house, kidnap your dog, and scratch your car with a potato while crunching those numbers. Amazing. For instance, when we were making a binary search tree, we didn't insert an element into a tree by modifying some tree in place. Our function inserted into a binary search tree actually returned a new tree, because it can't change the old one. Yeah, I had a problem with that yesterday. Returning new list instead of... Yeah, I was thinking that we're using the old list, but we're not. We're returning a new list. Important to remember. Good thing to reiterate. While functions being unable to change state is good, because it helps us reason about our programs, there is one problem with that. If a function can't change anything in the world, how is it supposed to tell us what is calculated? In order to tell us what it calculated, it has to change the state of an output device, usually the state of the screen, which then emits photons that travels to our brain and change the state of our mind. Man, oh wow, someone has been eating the mushrooms, eh? Colgitinotab says, it is nice they illustrated imperative language, like kidnapping a dog. That's what you're doing. If you're an imperative programmer, you're as bad as a dog napper. No, it says, yeah, when the dog got kidnapped, I felt that. It's so awful. We have to stop using imperative languages altogether because we can't, right? We don't want to be liars. We don't want to be dog nappers. Do not despair, all is not lost. It turns out that Haskell actually has a really clever system for dealing with functions that have side effects that neatly separates the part of our program that is pure and the part of our program that is impure, which does all the dirty work, like talking to the keyboard and the screen. Wait, are those side effects? Right. Functional programming just tells stuff. Yeah, we're just saying what stuff is. Printing to the screen is not... That's a command you give the computer. Print. The print command is a command. can't really tell that something was printed, something is printed. Can't you do that through functional programming? Let's just assume you can't, because that's what it seems like. That's what we're saying. Right. With these two parts separated, we can still reason about our pure program and take advantage of all the things that purity offers, like laziness, robustness, and modularity, while efficiently communicating with the outside world. Hello world. It is time. Up until now, we've always loaded our functions into GHCI to test them out and play with them. We have. We've also explored the standard library functions that way. Yep. But now, after 8 or so chapters, we're finally going to write our first real Haskell program. Yay! And sure enough, we're going to do the old Hello World shtick. Colgate Untitled says, printing is a side effect. It changes your state of mind, man. Yeah. It affects your ego. Just how you experience reality. Oh, man. Side effects, they are important, I guess. Hey, the purpose of this chapter... Wait. For the purposes of this chapter, I'm going to assume that you're using a Unixy environment for learning Haskell. We are using a Unixy environment. Yeah. If you're in Windows, I'd suggest you download Cygwin. No. Don't suggest that. If you're on Windows, I suggest you switch to Linux. Which is a Linux-like environment for Windows, aka just what you need. You need a Linux-like environment. That is what you need to improve your life. I'm not at all biased. No. These are facts, not opinions. Facts. That's how it works. So for starters, punch in the following in your favorite text editor. Right? I'm gonna punch this into my favorite text editor. Actually, let's go into here and learn you a Haskell. Oh wow, we're getting... No, let's remove the the text file. What is the geometry thing? Vim geometry. I don't even remember that. Let's remove that one. Remove the geometry one. What about the wolf? Oh, that's probably just one of the... Yeah. One of the Code Wars things. Right. So vim hello.hs. Right. Let's zoom in so you can see what we're typing. Right. Main, which is put string ln. What does ln stand for? Put string ln, the world. Why couldn't we just name it print? Ignore this message, says NodeRunner. Alright, I'll ignore that message. ln is new line, is it? Oh, put string on a new line. Line new. Okay. Boom. We put it. Oh shit, I need to... Been thinking about this. Maybe I should use a different web browser where the text doesn't come this. Or what we do is that we just right quit that. We have this and we just switch over here. And we go to Vim and hello. Right. Here we go. Now, and we'll leave GHCI like this. And we clear the screen. Another one says that LibreWolf is nice. Oh, I'm glad to hear it. I'm happy to hear that. I'm super curious about what that line was. I'm assuming it's part of the idle game, right? It was purely text idle game, right? We just defined a name called main. And in it we call a function called putStringLine with the parameter hello world. Looks pretty much run of the mill, but it isn't, as we'll see in just a few moments. Save that file as helloworld.hs. I will not. I'll save it as hello.hs. Now Donner says they're just codes for free stuff in the in-game shop. There we go. Free stuff, lovely. And now we're going to do something we've never done before. We're actually going to compile our program. Oh, finally. Yeah, I'm so excited. Me too, yeah. Open up your terminal and navigate to the directory where helloworld.hs is located and do the following. You know what? I can do this. When we do compiling stuff, we don't need a lot of space. We can do it down here. Over there. CD stuff in here, right? Colgatin on tab says, be careful now. IO has side effects. It could kidnap your dog. Luckily, I don't have a dog. Hopefully they won't kidnap my cat. That would suck, wouldn't it? Right. Global... No. Glasgow Haskell compiler. Then we just dash make. And then hello. We don't even put the .hs. Compiling. Right, we're compiling main. Alright, so it's like C that you have to have a main function, so to speak. You have that, and you have to have that in C as well, right? And then linking hello. Alright, what did we get? Shit. Need a little bit more space, I think. Little bit more space so we can see all of that. No? More space than that, eh? What about that? Is that okay? Yeah, that's probably fine. Alright. So we have, here we got our program. Executable from the get-go. /hello. What happens when we try to execute it? It says hello world. Look at that. We've compiled our first program. Feels good, man. Feels good. Okay, with any luck, you got something like this, and now you can run your program by doing ./hello. I didn't name my hello world, I just named it hello. We also got this. This is something else we got. What is that? Hello.hi. If we quit here and then we go to Vim, oh, we can close this down, and then we go to hello. Was it I? No, E? No, hi. Oh, is that the... Oh, we got hello O as well. Hello. We got a lot of files, didn't we? Yeah, 2 binary files. And an executable. What is the... is that just a link? Oh. That's a mess. We got a lot of stuff, didn't we? Look at this. This is my file. This is the executable that we linked, and then we got these 2 files. that I'm assuming we're learning about very soon. And there we go, our first compiled program that printed out something to the terminal. How extraordinarily boring. Is it? Is that boring? No, alright. Let's examine what we wrote. First, let's look at the type of the function. Put string on line. Right. Check for the type. It takes a string and return an IO. With a parentheses? What's with the parentheses? The old in-out. Time to rewatch that movie. Clockwork Orange, great movie. And type put string hello world, put string. Okay, so it creates. Right. We're telling Haskell, right? We're functional. We're telling stuff what stuff is. So this function creates a new data type. It's a data constructor. I don't know this, right? Put string. We get this data type, and it is of. I don't remember what the double colon was. It's definitely an IO thing, though. IO is for input output, I'm assuming. We can read the type of put string on line like this. Put string line takes a string and returns an IO action. Returns an action, actually a command that has a type of IO action that has this type. Right, I was thinking this is like type class stuff, maybe. That is the empty tuple, also known as a unit. An IO action is something that, when performed, will carry out an action with a side effect. Wait, so the whole thing with functional programming is that we don't want side effects, but it feels like the whole design of functional programming is kind of broken because, well, we have to have side effects somehow. That how it is? That's usually either reading from the input or printing stuff to the screen. And will also contain some kind of value inside it. Printing a string to the terminal doesn't really have any kind of meaningful return value, so the dummy value of an empty tuple is right. We're just printing to the screen as a side effect, but we're not returning anything, and since Haskell is functional, it always has to return something, so it just returns an empty tuple. It returns an empty unit. It's like when you write your main in C, right? You always return 0, and it's the equivalent of returning 0, right? Our main function is just, instead of returning 0, we just return an empty tuple, i.e. a unit. The empty tuple is a value of an tuple, yeah. It also has the type of a tuple. Sure. So when will an IO action be performed? Well, this is where the main comes in. An IO action will be performed when we give it a name of main and then run the program. Right. So that's pretty much what you do, right? When you write a long... Yeah, when you code something together, you have just, I don't know, a list right? You have a lot of functions that do things. And then at the very end, you have a main function that glues all your stuff together and does whatever you want it to do. So that's what we have in Haskell. We have a main function, just like in C or whatever, that glues everything together and does all the things. Well, we have all our other functions that define what all the things are that are used in the main function, right? That actually makes a lot of sense to me, that we only have one. We have one I/O function in our program. Having your whole program being just one I/O action seems kind of limiting. Isn't that usually how we do things? That's why we can use do syntax to glue together several I/O actions into one. Take a look at the following example, right? Main do. Oh, right. Do this, do that, and do this. Hello, what's your name? Get line, that's another I/O thing, right? I/O action, and I/O action. Right, so our main function, we do it, oh shit. Vim hello dot, oh man, annoying that they all have the same name. Right. This will only do one thing, but if we do it like this, we can do a lot of stuff. What was this thing? Name. And get, what was it, get line? And then put string on new line. Hello. Yeah, like that. Let's try and make hello. Nope. Shit, what did I do? Oh, it all has to be in parentheses. Of course it has to be. Wait, does it have to be, or can we do the $sign? $sign should work, right? Yep. And then we do / hello again. Now we didn't tell anyone to do, so it looks like it's just blinking here. What's going on? We don't know. So we say, hello, McDread. Oh shit, no space. Right, we have input and output. Ah, interesting, new syntax. And this reads pretty much like an imperative program. It does, yeah. If you compile it and try it out, it will probably behave just like you expect it to. It did indeed. Notice that we said do, and then we laid out a series of steps like we would in an imperative program. Each of these steps has an I/O action. By putting them together with do syntax, we glue them into one I/O action. That action that we got has a type of I/O and then an empty tuple, yeah, because that's the type of the last I/O action inside. Man, I feel warm and fuzzy now that we can think like imperative programmers again. Shit. We're not supposed to do that. We're supposed to think functionally. Because of that, main always has the type signature of main I/O something, where something is some concrete type. By convention, we don't usually specify a type declaration for main. An interesting thing that we haven't met before is the third line, which states name and then arrow into get line. Looks like it reads a line from the input and stores it into a variable called name. Does it really? Well, let's examine the type of get line. Outrunner says, life is side effects. Try as you may, entropy gets to all of us in the end. It does, doesn't it? Oof, that's dark. That's, yeah, entropy, the big enemy, I guess. That we probably, I mean, there are people thinking that maybe one day some life will beat entropy, but see about that. Right? Escaping this universe to another universe, I suppose. Right. Get line is just an IO string. Ah, okay. Get line is an IO action that contains a result of type string. Right, it's an action an IO action that contains a string. Right. Specifically this string. Or to be exact, right? Get line. That's the string we get. So what's up with the name and then the arrow and get line then? You can read that piece of code like this. Perform the IO action get line and then bind its result value to name. Get line has a type of IO string, so name will have a type of string. Right, so we have created a string pretty much. You can think of an IO action as a box with little feet that will go out into the real world and do something there. Like write some graffiti on a wall and maybe bring back some dogs. Pulgitin on tap says, we have seen the arrow before. Do you remember where? This arrow? No. I don't remember where, no. Beat entropy, says Noderunner. Entropy isn't something to be beaten, it's the reason why we're here. I always forget. Alright. Entropy. I need to just sidetrack for a second here. Entropy is a scientific concept as well as a measurable physical property that most commonly associated with a state of disorder, randomness, or uncertainty. The term and the concept are used in diverse fields. Yeah, we're created from entropy because stuff changes, right? Yeah, stuff goes from order to disorder. However, life as it is, right, has a not stated goal, but it has a goal of, right, you build up a structure of ordered things, you order stuff up and you want to keep that order. Right? When you build a house, you don't want the house to crumble into dust. You want the house to keep standing. When you build a human body, you want that human body to keep on functioning and not crumble into dust. Entropy is kind of like entropy has put us in, like the chaos has put us in the situation where the body is allowed to exist, but it also fights against it. So I don't know. Right, enlist comprehensions. Right. because we decided what the X was in the list comprehension. Man, we haven't done list comprehensions in a while. That's weird. Yeah, but we took X and we put something into the X. That is, yeah, we bind X. That's what they call it, right? Take X here and we bind X is, and then we define what it is, right? We had our, what were they called? We had premises, no? We had rules. We did pattern matching and whatnot on the other side of this icon, and then we bound the result to X. Right, but name will have a type of string. You can think of an IO action as a box with little feet that will go around and kidnap dogs. Yeah, we get that. We're gonna kidnap dogs with IO. Once it's fetched that data for you, the only way to open the box and get the data inside is to use this construct, binding it. Right, because when we bind it, after we have bound it, we have decided this is now functional. We go out and collect something in the world, and then we bind it to something immutable. Predicates are what they're called in the list comprehensions, by the way. Predicates. Thank you, Colgate. On that. Node owner says, imagine flipping a coin. It's random, right? Oh, are we having this discussion again? It depends on how you look at it, right? Random is a word, in my mind, how I look at random is that it's a statement about me when I flip the coin, is that it's random because I cannot predict what side the coin will end up in, right? Therefore, it is random, but that is not a statement necessarily about the world. It is a statement about me not being able to predict the coin flip, where it will end up. So, yes. Okay, yes, it's random. That's probably the easier way to go, isn't it? Yes, flipping a coin is random, sure. Node runner continued. But you will often find... You'll often find that you'll find patterns in that entropy. Sure, it's heads, heads again, heads again, heads again, heads again. A surprising amount of times. Node runner is proposing that human life is a random occurrence in the universe similar to flipping heads 100 times. A pattern in the void that created structure where none exist. Yeah, right? Entropy is a tendency. And of course you get pattern from within that stuff. I would agree that sure, it's a random occurrence. Similar to that, yeah. It sounds very similar to that. What do they call that? The Goldilocks stuff. Goldilocks zone. Shit, I don't remember. I'm terrible with names. Right? We find ourselves on a planet where it just works, right? It's a random occurrence that the planet just ended up in this range from the sun, and the planet is built up with exactly these types of molecules, right? Like you said, right? Head, head, head. All these things came together and voila, now you have life. Right. And something, that life, when you flip head 100 times, a random occurrence, if you will, is that the stuff that has been created by those 100 flips of head is that we find a being that wants, when they flip the 101st time, they again want to have head, right? We have intention, we have wants and needs, right? Sure, it's a random occurrence, but we do want another head. Like, who doesn't want head, right? Right? Everybody wants head. That's just the case of life. Life in a nutshell. Everybody wants head. And that becomes a fight against entropy, right? Because odds are, sooner or later, we will not get head. But we do want head. Nodunner says, I want some tail personally. Right, sure. Oh man. Oh, hilarious. Oh, Get In on Tap says people are pretty good at pattern matching. I don't know. It depends on how you define pattern matching. Nodunner said, and like that pattern of sequential heads, it will eventually end. So too will us. Right. But that's the thing, right? That's one of the goals of humanities. It's about trying to... I mean, eventually there will be no more head, and finally we will get some tail. Finally you will get your wish. But that doesn't mean that the stated goal is to continue getting head forever. Right? Entropy is a thing, right? Just like everything so far that we know of has died, right? All living beings die, but that doesn't mean that a spoken goal for humanity is not to be immortal, right? The goal is to be immortal. And we don't know if that's achievable or not. It might be, probably won't be. Get In on Tap says it will almost surely end eventually. Yeah, right? Those are the odds, right? The odds are against humanity. Just like if I want to live forever, the odds are against me. Because I will almost surely die at the end. Nodunner says forever? I don't think so. Maybe an hour at the most. Maybe. But the goal is still there, and I think the goal is a worthwhile goal. Even if it's a naive goal. Yeah, I think a naive goal, it's still a goal, right? It's the idea of utopia. The idea is inherently built into the idea is impossibility. It is impossible to achieve utopia. But that doesn't make it a bad goal, right? It's not a bad idea to try to imagine the best type of society you could build and then strive for that. Nodunner says people are good at finding patterns where there are none. Yeah. Like seeing shapes in the clouds. That's not the same as flipping heads 100 times. That's an actual pattern. Doesn't a pattern need an observer to tell that it is a pattern? Probably not. Probably not. Right. A bit of a sidetrack. Interesting. Right. We have a construct, and if we're taking data out of an I/O action, we can only take it out when we're inside another I/O action. That is how Haskell manages to neatly separate the pure and impure parts of our code. GetLine is, in a sense, impure because its result value is not guaranteed to be the same when performed twice. That's why it is sort of tainted with the I/O type constructor. And we can only get that data out in I/O code, and because I/O code is tainted too, any computation that depends on tainted I/O data will have a tainted result. Wait. I'm confused. Doesn't that mean that everything is tainted? Because what is the point of a program? We get some output, we do a lot of stuff, and we give some output. We get some input and we give some output. doesn't that mean that all the stuff we do is tainted from the get-go? Node says, if a bear shits in the woods, does it make a smell? Wait, what? Yeah, for sure. Sure, it makes a smell. And a bear do shit in the wood. That made me think about my favorite insult, or a non-insult. If you want to do a non-insult to someone, just tell them, you smell like snot. My favorite non-insult. Well, Get In on Tap says we're just gonna keep reading onwards. Here. When I say tainted, I don't mean tainted in such a way that we can never use the result contained in an IO action ever again in pure code. Now we temporarily untaint the data inside an IO action when we bind it to an... Oh, right, yeah, exactly. That's what we did. We took it and we made it pure. I said that like 10 minutes ago. No, that was probably 20 minutes ago. We bind it to a name, and then by the binding we untaint it. Because, right, since we bind with, where is it? With getLine. getLine creates a string, so therefore we do have a string. No, Donald says, I do snot. Yes, you do, No Runner. Smell like snot. Right, when we bind getLine to name, name is just a normal string. There we go. So from here, we have a normal string. That string we can... Wait. How do we move it out of the main function? Oh, we can just call a function, right? I can just... let's see, I can do... we do a function called... No, actually, we don't even have to name my own function. Can't I just do... reverse name? Shit, no, I need to print it. We do... Wait, how we do that? rname is equal to reverse name, and then we just print rname. Yeah. Here you go. This... Does that work? Let's try it out. I'm curious if that works. Because if it works, then this here is a functional thing, right? This is... We're doing untainted stuff. And here, we retaints it. Right? Well, here we get something tainted. Well, we get something tainted. We untaint it. We do some functional stuff on it. And we retaint it. Well, we don't do. We define some functional stuff. No? Parse error input on equal. Perhaps you need a let in a do block. That is let x equal 5 instead of x equal 5. Right. Shit. That's... I still didn't get the let thing. Is that how we... Since we are in an untainted environment, within our tainted environment, we create a string, but we have to let. Yeah, that works. And then we do Siga again, and my name. Yeah. define it. We now have a reversed string. We define what that is. Right, so let, I assume, is just a way to get... That's why they were saying all the time in GHCI that we should do let, because GHCI is probably happening within a do statement. That that interactive mode, we're probably working... Yeah, because we're putting strings out all the time. We're printing stuff all the time in GHCI. That's why they told us to do let, because just to make sure that we're doing stuff functionally and not imperatively. Flipping back and forth. We don't do this. We don't reverse the name. We just define that our name is the reverse of name. So in empirical, is that what it's called? I'm terrible with names. Empirical to functional, and then empirical again. All right. Name is just a normal string, yeah, because it represents what's inside the box. We can have a really complicated function that, say, takes your name, a normal string, as a parameter and tells you your fortune and your whole life's future based on your name. We can do this. Main do, boom, get the name, and we can make a function that we have somewhere else, the name that we join in. Yeah. Just like I did with my... Oh, wait. So can I do it... I could have just done it this way, right? What they're saying? Yep. In here we didn't have to let, because I didn't create a variable. I have to let to create a variable, but here it's just a string. Just a string. Right, because we're doing things. Yeah, we're doing things. We're doing actions. And the action is let this happen. Let this be a thing. There we go. Colgate Innotab says function, not variable. Shit, I lost the context of what I said before that, what you meant. Oh, right, we created a function. Yeah, we created a function. This is the function. We didn't create a variable, we created a function. Our name, which reverses name. Yep. Sorry, thanks for checking out. Or checking out? No, that's not. Looking out. And tell fortune or any of the functions it passes name to doesn't have to know anything about IO. It's just a normal string. It's just a normal string-to-string function. Indeed. Take a look at this piece of code. Is it valid? Name tag. We take a function. Hello, my name is getLine. No. Because a getLine is an IO thing. This is a function, and this is an IO thing, so it doesn't work. If you said no, go eat a cookie. Oh, okay. Sorry, I thought that was funny. Yeah. Not owner says, fun fact, there's an application called imgcat, which prints images to the terminal. Nice. Prints images. I'm assuming it's dependent on that. What is that called again? Oh, right. ImageCat. Of course. Great name for the program, isn't it? It works in Foot. Actually, how are you enjoying Foot, NodeRunner? You've been using Foot for a while, right? As a terminal emulator? If you said yes, drink a bowl of molten lava. Oof! He's harsh, isn't he? Just kidding, don't do that. The reason that this doesn't work is that ++ requires both of its parameters to be lists over the same type. Yeah, this is not a list, this is an IO string. Kinda, yeah. NodeRunner says, it's like cat for images, except it's not at all, because cat's purpose is to concatenate files, not to view them. Alright, yeah, it's like cat, but not at all. Exactly. NodeRunner says, Foot is really good, no problems to report, everything worked. Man, gotta get that Foot up and running, gotta try that as well. Actually, I'm sorry, I'm just gonna fix that real quick. Vim, and we're gonna change, where is that? In my stuff. It's not the flake, no, but it's the packages. Then we go up here, this is all my packages I have, and the alphabet. Probably here, isn't it? But there we go. And also git commit added put, then git push. Wait, oh shit, I'm in the wrong directory, aren't I? There we go, now it works, and now we do git push. I'm sorry about this, I just would have forgotten about it again, and I don't want to forget about it, so I'm just doing it right now. There we go. Fixed. Colgate says, is there an img lolcat? No, but there is lolcat. Oh, you do it in Home Manager, programs.foot.enable. Shit. Do you need to do it in Home Manager? Why? Foot and FFmpeg are in reverse alphabetical order. Shit, I didn't even see FFmpeg there. But yeah, I put them at the wrong spot. Why do I want to do Foot in my Home Manager instead of my packages? There is also a server/client mode. Oh, I probably want that, don't I? A server mode? That sounds great. And you use a lot of terminal emulators. Right, lists of the same type. The left parameter has a type of string, or list of characters, if you will, whilst the getLine has a type of IO string. That's unacceptable. Can't concatenate a string and an IO action. First have to get the result from the IO action to get a value of type string, and the only way to do that is to say something like name getLine, right? Yeah, bind getLine to a name inside some other IO action. If we want to deal with impure data, we have to do it in an impure environment. So the taint of impurity spreads around much like the undead scourge, and it's in our best interest to keep the IO parts of our code as small as possible. Every IO action that gets performed has a result encapsulated within it. That's why our previous example program could also have been written like this. as a result encapsulated. Main do foo. Wait, what is this? Is that the string? No, this is nothing, right? Yeah. Foo would only have a value of an empty tuple. Yeah. What I thought. You can also manage your foot config with Home Manager. Alright, I have an important next question here. How do I know what I want to put through my Home Manager and what I want to put through my Nix install? Where do we draw the line, right? What should be done in the Home Manager and what should be done in the... Is it just anything that I want to have configurations of, where I want to have my own unique configuration? Then I'll run it through Home Manager. Is that the way to think about it? So doing this line would be kind of moot. Yeah, we would just create an empty thing here. Node owner says Home Manager is for your user. My user? That's me. Yeah, I'm the user. I'm thinking that's... Oh, you run foot as a user. Oh, so everything I don't run as root, we could put in my Home Manager. That is why, for example, Vim is very good to have not in your Home Manager, but, or NeoVim that I have, but instead have it in the Nix config, because sometimes you would want to edit stuff as root, not as a user. You want to edit as root. So it's a good idea to put that stuff. Right. That makes sense. Everything I want to run as root ends up there. The rest in Home Manager. So most stuff will end up in Home Manager, really. Alright, notice that we didn't bind the last put string length to anything. That is because in a do block, the last action cannot be bound to a name, like the first two were. We'll see exactly why that is so a bit later when we venture off into the world of monads. I think this is the first time we've seen the word monads. For now, you can think of it in the way that the do block automatically extracts the value from the last action and binds it to its result. Oh, right. We are already doing that within the main, so therefore the last one we can't bind it to something else because that's what we did here. Node owner says I have two Vims, Vim for root and NeoVim for user. I don't use Vim as root much, but when I do, I want it to be there. But I don't need all my plugins and whatnot. That's something that made me super happy, that I want all my plugins and whatnot. Because I want to feel like home. Yeah, I want to feel like home. Oh, you made some more sick ANSI artwork for my Steam profile yesterday, says Steam. Let's check it out. Oh shit, that was... Oh yeah, this is looking pretty good. Table. Seashell. Window Manager. i3. Still? That doesn't look right. Teaching sand to think was a mistake. Wait, who said this? Also, I don't know. Maybe it will turn out to be a mistake. Got a few achievements, yeah. Got a few perfect games as well. Average completion rate, 98%. Oof. I love this one. Ah. Beautiful stuff. Oh, gross. Just a few? What does average completion rate mean? Asks Colgating on tap. How many achievements you got in each game, right? The average amount of achievements you got per game played. 98%. Yeah. Outrunner here takes his achievements very seriously. Yeah. Play all the games to completion. Such a completionist. That is what happens. Right, Outrunner? You're not cheating at all. There's no cheating. Use that word again. Yeah. I think it's the second time we've seen that thing. It's great. I like this profile. Outrunner says, I take it very seriously. Yeah, play all the games completely. That is what I thought. Sorry, no, we got sidetracked again. Yeah, he plays all the games completely. It's actually on the top of the list of most achievements earned on Steam. There is a list somewhere, and Outrunner was on top of that list. Where were we? Alright, except for the last line, every line in a do block that doesn't bind can also be written with a bind. So put string blah can be written as, you can bind it to nothing, right? But that's useless, so we leave out the binding for IO actions that don't contain important result, like put string something. Yeah, when we print stuff out, we... What is with this name? Why didn't they just name it print? Why isn't this called print? Put string line. Ugh. Beginners sometimes think that doing name is equal to get line will read from the input and then bind the value to that name. Yep, that's what I would have done. Well, it won't. And this does give the getLine IO action a different name called, well, name. Oh, right. Yeah. We're just saying that name is getLine. Remember, to get the value out of an IO action, you have to perform it inside another IO action by binding it to a name with the bind thing. IO actions will only be performed when they are given a name of main, or when they're inside a bigger IO action that we composed with a do block. We can also use a do block to glue together a few IO actions, and then we can use that IO action in another do block, and so on. Either way, they'll be performed only when they eventually fall into main. Alright, so there's also one more case when IO actions will be performed. When we type out an IO action in GHCI and press return, it will be performed. Yep, what I thought. So GHCI is built. Even when we just punch out a number or call a function in GHCI and press return, it will evaluate it as much as it needs and then call show on it, and then it will print that string to the terminal using the print function. The print action? What do we call that? Is it an action instead of a function? Maybe we should call it an action. Colgate says, now that you know Hello World and the chapters prior to it, does it make sense that they didn't teach Hello World before chapter 9? No, I still think that the previous chapter should have come after this. Yeah, this should have come before the previous chapter. So yeah, but it makes sense. A lot of the chapters that we had before, it makes sense that we had before this chapter, for sure. Yeah. Node says, I'm ranked number 1241 for most games on Steam. Oh wow, that's... Oil Prince is number 1. Oil Prince, who is that? It sounds like an... Oil Prince, yeah. Assuming they own all the games. That's a lot of games you have on Steam. Remember let bindings. If you don't, refresh your memory on them by reading this section. They have to be in the form of let bindings in expression, where bindings are names to be given to expressions, and expressions is the expressions that can be evaluated that sees them. We also said that in list comprehensions, the in part isn't needed. Well, you can use them in do blocks pretty much like you would use them in list comprehension. Check this out. Right, import data.char main do. Right, what's your first name? And then we get first name, and then we ask what's your last name, get the line, and then we do let big first name, and we do get them to upper, and we get big last name to upper, and then we put them in here. The in is not... Why is the in isn't needed? Let it be. Do we have to reread this? Not rereading this today, I don't think. How long do we have to go? Oh wow, this is a long... Brilliant. Actually, I think that's a good spot for taking a break. I don't remember. Should I just rewatch my old video of doing this, or should we read this section again the next time, the let bindings? Right? So yeah, the structure of the text so far, we have let it be here. Where are we? Syntax in functions. Where is that? Syntax in function, right? That's chapter 4. Let it be. That should have been closer to version. Maybe, do we need higher order functions first or compiling first? Yeah, I think we could have had Hello World here, couldn't we? Then we could have learned about the... So far, right? We haven't finished the chapter on input-output. But yeah, we could have definitely gotten Hello World way earlier, I think. Node says that the estimated cost is 34,000, almost 35,000 US dollars. Oof. I looked up exactly what Foot does in Home Manager by reading the module. It is pretty simple. It just activates the package for you, lets you configure it, and starts a systemd unit if you have the server enabled. That is, yeah. I do want a server enabled for foot. Right, but I think yeah, I think that's enough reading for today, and maybe we can do day 3 here before lunch. Might be a little bit late to lunch, but yeah, that's it. Oh shit, my green screen is all messed up, isn't it? That's not too good.